Hi, I'm Kelly, and today I'm going to show you how to do question 6 for FRQ 2005. And this question is about differential equations and slope fields. So it says, consider the differential equation dy over dx equals negative 2x over y. So dy over dx is the slope of the tangent line at any point, so I'm going to write that. So you can use this to do all these problems. So for part A, it says, on the axis provided, sketch a slope field for the given differential equation at the 12 points indicated, which are these points. And so the first point that I'm going to do is 0, 1. So 0, 1. And to find the slope, you plug in this coordinate to this. So x would be 0 and y would be 1. And you simplify that, and you get 0. So you can draw a line here that represents the slope 0. So a trick that you can use is that for the points that are on the y-axis, they all have the x-coordinate 0, so the slope will always be 0. And you know this because when you plug in 0 to this equation, you get 0 on the top, and any fraction with 0 on the top is always 0, so you can just draw the slopes. And now I'm going to do the point 1, 1. So I'm going to write down 1, 1. And you do the same thing as this. So you plug it in, and then you get negative 2. So you just kind of eyeball it, and you go down 2 over 1, and you draw a line like that. And then another trick that you can use is that you know that the coordinates here are positive, and the coordinates here are both negative, and a negative number on top of a negative number is positive, so it kind of cancels out. And so the slope at this point would be the same as the slope at this point. And I can show you that by doing negative 1, comma negative 1, and plugging it into the differential equation. So, like that. And you cancel out the negative 1, and you get negative 2. And it's the same over here, so negative 2. And then so that means the slope at this point would be the same as the slope for this point. So I'm going to find this point, which is 1, comma 2. And that simplifies to negative 1. So I go down 1 over 1, and you get that. And then this is also negative 1. You get 1. So now you have to find the slopes for the points in the second quadrant and for the ones in quadrant 4. So it's the same as this. The slope at this point would be the same as this point. Negative 1, 1. And that simplifies to 2. So you can go up 2 over 1. You draw a line there. And then this would also be 2. And then now I can do negative 1, comma 2. And this simplifies to be just 1. So you go up 1 over 1. And that's how you do part A. So now I'll do part B, and it says, let y equals f of x be the particular solution to the differential equation with the initial condition f of 1 equals negative 1. Write an equation for the line tangent to the graph of f at 1, comma negative 1, and use it to approximate f of 1.1. This means that the point that they're giving you is 1, comma negative 1. And now I will find the equation of the tangent line. And you can do this by using point slope form, which is y minus y1 equals m times x minus x1. And you know what y1 and x1 are already, because they give it to you here. So I'm just going to write 1, negative 1, and now you have to find m. So m is the slope of the tangent line, and this is the slope of the tangent line. So I'll just use this to find the slope. So you do dy over dx equals negative 2x over y. And the x and y are the x and y. So you do negative 2 times 1 over negative 1, and you get 2. So then you can use the slope and the point and plug into the point slope form to get your equation. So y plus 1 equals 2 x minus 1. So the second part is to approximate f of 1.1. So all you have to do is plug it into the equation that you just found. And because this equation is the equation of the tangent line, and the tangent line is just approximation, so you can just plug it in, and you do y plus 1 equals to 1.1 minus 1. And you can just simplify, so you get and then in the end you should get negative 0.8. And now I'll do part C. And part C says, find the particular solution y equals f of x to the given differential equation with the initial condition f of 1 equals negative 1. Point is 1, negative 1. First, I would write down my information, so you know the point 1, negative 1. And it says you have to find the particular solution to the given differential equation, which is negative 2x over y. So dy over dx equals negative 2x over y. And you have to find what y is. To do that, you cross multiply. So you get y dy equals negative 2x dx. And then you have to get rid of the dy and the dx, so you integrate. And then when you integrate, you get 1/2 y squared equals negative x squared plus c. And this plus c is really important. C stands for a constant, and because the derivative of any constant is always 0, so you don't know if there was a constant here or not, because just by looking at negative 2x you can't tell because it's just plus 0. So you have to have a plus c there to represent the constant. So the next step would to find what the constant is, and how you do that is by using the coordinate that they give you. So you plug in negative 1 in y squared, and then 1 in negative x squared. So, and then you move 1 to the other side, and you get c equals 1/2 plus 1, which is equal to 3/2. So after you find c, you can plug it into this equation. And then you would get 1/2 y squared equals negative x squared plus 3 over 2. And then you have to find y. So then multiply both sides by 2 to get rid of the fractions. So 2. And then to get just y, you take the square root of both sides. So now you have to determine if this is plus or minus. And you know it's negative because the initial condition is 1, negative 1, and the y value is negative, so this must also be negative. And if you want to make it prettier, you can do negative square root of 3 minus 2x squared. And that's how you do part C. So in my opinion, these questions are not that bad. Maybe C would be a little bit trickier, but if you remember to do the plus C, then you're basically fine. So if you look at the answer solution, the scoring guideline, you know the plus C is really important because if you don't have it, then you can't do the rest of this problem. So this whole part, and that whole part is 3 points. And you have to have the plus C because it shows your understanding of integration. And also, if you don't separate the variables, then you can't get any points. And the separation of variables is basically when you cross multiply to get the y side and the x's on one side. And if you want any practice problems that are related to this problem that we just did, there'll be links in the description box. So thanks for watching.